So our group studied the density and the viscosity of the dough using 4 different types of fats, which were butter, margarine, sunflower oil, and coconut oil. I personally considered this experiment from a biological point of view, so I created a comparison table of 4 fats we used and then evaluated them based on 5 criteria, namely the origin of those fats, their biological properties, the effect on the human body that they had, and the effect on the density of the cake, my assumptions, and the final results. As my research, I came to the conclusion that the coconut oil is the healthiest one for the human body because it contains large amounts of saturated fats and acids, which are subject to oxidation, unlike the other vegetable oils like margarine and the sunflower oil. And those fats and acids impart fluffiness and lightness that are stored for a long time in those cakes. Frankly, our coconut oil cake was the most flimsy, airy, flavorful, and pleasant one to taste, and it is also worth noting that the butter cake was in the second place in density. Butter is ideal for making sponge dough because it is enriched with many vitamins that are useful for the human body, and it is almost 100% absorbed by the body. And because it melts easily, the butter dough turns out to be moderately dense and airy, second only to the coconut oil. From the above, it follows that all 4 kinds of oils we used are well suited for baking, but the airiest and at the same time the healthiest one is the dough on the coconut oil.
Initially, it must be stated that all ingredients were stored at a room temperature for optimal emulsification. From a physics lens, we can analyse the effect of varying fat sources on density of the cake through the bubbles formed in the batter. So in making the batter, I used the method of creaming the fat with the sugar, and in doing this, I incorporated air pockets into the batter. And this was important because these air pockets created from the mixing of the sugar through the crystallized structure of the sugar, digging into the batter and making these air pockets meant that other gases like water vapor from the moisture or carbon dioxide from the baking powder can migrate into them and expand when heated. This creates, or this increases the overall fluffiness of the cake, or makes the cake less dense. When creaming the fat and sugar, if the fat source were to be too cold, so if I hadn't used room temperature, then this wouldn't have been possible. From my data, I saw that the densest cakes were those with the smallest pockets of air. I measured at random 5 bubbles of varying sizes on each cake and then averaged my results. My results showed the margarine had an average bubble size of 0.22 centimeters, which was considerably less than any of the other examples, with butter 0.32, sunflower oil 0.34, and coconut oil 0.4. Hence, I can acknowledge that margarine is most dense and butter was the least dense, as butter had a fluffier texture in the end. And to prove that this is the case, I used different techniques of testing the cake. For example, I analysed the crumb of the cake and explored the required weight to depress a 3.5 by 5 centimetre square section of each cake by 1 centimetre deep. Through analysing the crumb of the cake, I was able to, through a sense perception, acknowledge the density of cake. Although this is a highly subjective method with risk of some form of human error or wishful thinking, I believe the margin for difference between the densities of the cakes were actually enough to note differences. And through such analysis, I noted through taste and visually that for the margarine and sunflower oil, both tasted rather dense compared to the butter and coconut, which both had a lighter and fluffier texture to them. Also, I looked at the weight, and for this method, I was testing the fluffiness due to the resistance being reflective of the overall structure and density of the cake. my results again showed the theory was correct, and that the butter and coconut were harder to compress due to their springier, lighter structure being less dense. And for the butter, it took 235 grams to depress, and 220 grams for the coconut oil. These cakes, they withheld their structural integrity better due to the creation of larger and stronger bubbles. Whereas on the other hand, the margarine only required a 190 gram weight to depress by 1 centimeter. The one outlier to the theory was the sunflower oil, which only required 180 grams of weight, even though its cake had the second largest bubbles on average. Perhaps my method of recording the bubble size proved to have some level of error to it. Maybe by baking multiple cakes for each, it would have proved to have more reliable results.
Sunflower oil is a non-volatile oil pressed from the seeds of sunflower. It is primarily composed of linoleic acid, a polyunsaturated fat, and oleic acid, a monounsaturated fat. Coconut oil is a saturated fat composed of the fatty acids caprylic acid, capric acid, lauric acid, myristic acid, palmitic acid, stearic acid, oleic, and linoleic acid as well. Butter is 50% saturated and 50% unsaturated fat composed of milk, fat, triglycerides, water, milk solids other than fat, which is curd. Margarine is unsaturated fats composed of vegetable oils, canola and sunflower oil, water, and salt. Polyunsaturated fats are simply fat molecules that have more than one unsaturated carbon bond in the molecule. This is also called a double bond. Saturated fats are simply fat molecules that have no double bonds between carbon molecules because they are saturated with hydrogen molecules. The smoke point of oil is the temperature at which it stops shimmering and starts smoking, oxidation point. When the oil breaks down, they release chemicals that give food an undesirable or bitter flavor, as well as free radicals that can harm the body. Butter is richer in monounsaturated and saturated fats and is more stable when heated. Therefore, sunflower and other polyunsaturated oils they found generate high levels of damaging aldehydes. When fats and oils are heated or at or close to 180 degrees Celsius, their molecular structure changes through a process of oxidation, producing these chemicals called aldehydes. Vegetable oils such as sunflower oil release great quantities of aldehydes at high temperatures. Even inhaling the fumes when these oils are heated means you are ingesting aldehydes.